In the last video, we saw how to create functions, overload functions, and create function parameters. Today, we will see what are the two different ways of passing parameters to a function. Look at this function in front of you. It's called increment by 2, the return type is void, and it takes one parameter which is an integer called num1, and we're simply incrementing this num1 parameter by 2 and displaying the following message. Okay? Now, let's see how pass by value actually works. So let's go to the main and create a variable called num1 and it will store the value of 12. Now what I'm gonna do here is I'm going to write a simple before and after. So what I'll say here is I'll say cout before and I'll print the value of num1. Then what I will do is I will call or invoke the function called increment by 2. So increment by 2, and I will pass to this function the argument or the variable called num1. So it is the argument for the parameter num1 here. Okay, and so right now I'm going to copy this and paste it right here, and this will be the after. So before and after. Let's go ahead and run this code to see what will happen. Okay, so I'll compile first and then execute. As you can see, before, the value of num1 is 12. Inside function, it's 14. We incremented by 2. But after the function, or after executing the function, num1 is still 12. Well, why is that? Why isn't num1 14? We incremented by 2, right? Let's see why. So this right here is called a pass by value parameter. What this means is that as soon as you give the function an argument, like num1 for example, what it will do is it will create a copy of this value, of the value of num1, and it will use the copy that it created and affect the copy. So whatever it will do inside this function, it will use the copy of the original value. So whatever it does, it will affect the copy of the original value, not the original value inside memory. This is what pass by value does, and that is why we got this output. So inside the function, we got 14. That's because we used the copy of the original value and we modified the copy of the original value. But still inside the main, we got 12. That's because we didn't modify the original value, we simply created a copy of the original value right here and used the copy of the original value inside the function. That is why we got 14 inside the function, which represents the copy, and 12, which represents the original value that we didn't touch. It's still intact. Okay? So what to do if you want to modify the original value inside memory? Let's go ahead and see. What I will do is I will comment this out and I will rewrite the function. I will say void increment by 2 again. I will say int num1 and num1 plus equal to 2 and cout inside function like this and num1 with end-l, and let's put this arrow right here. Okay, now what is the pass by reference parameter? How to use it? Well, to use this pass by reference parameter, all you need to do is go up here to the parameter and simply add the ampersand before, or excuse me, after the type of the parameter. So what does this do? What means pass by reference? So basically, as soon as you pass to this function a value like num1 for example, so 12 right here, what it will do is it will use the original value inside memory. So when you pass it num1, it will use the original value of num1. It won't create a copy of num1 and modify the copy. It will use the original value of num1, which is 12. So it will go directly to the memory where num1 is located, and what num1 stores, it stores 12. So it will go to the original address of 12 and it will modify the original value inside that address. This is pass by reference. It will directly modify the original value in memory. So it's like giving you access to the memory and modifying whatever is inside this address. So now let's go ahead and run the code. Let's see what will happen. So if I compile first of all and then run, as you can see, before it's 12, after or inside the function is 14, as well as after the function is 14. Well, why? Well, basically, when you pass by reference, it will not create a copy of the original value, it will simply access the original value inside memory. So you pass the original value to this parameter, it affected the original value, which is 12, so 12 plus 2 is equal to 14. So the original value became 14, it was incremented by 2, and this simple message will be printed. And because we modified the original value inside memory, definitely right here we'll get 14 because num1 stores this value and you basically affected what is inside num1. So basically you will get 14 in here, right here, in this message, and right here also. And this is called pass by reference. And now let us do a simple quiz. Right now, there's two functions of same name. I want you to know which one is a pass by reference or pass by value. Of course, the one that has the ampersand right here is the one, or is the function passed by reference, or has a parameter passed by reference, and this one right here is passed by value. So basically, again, passed by value parameters are simply parameters that when you, or values that when you give it to a function, it will create a copy of these values and it will work on the copy of the original value, not the original value inside memory. So whatever it will do, it will only affect the copy of the value, not the original value inside memory. However, functions passed, or parameters passed by reference are simply parameters that when you give it to a function, or when you give to the function the value, what it will do is it will access or directly access the original value inside memory and modify the original value inside the memory, and it will not create a copy of this value. Okay, so this is passed by value and passed by reference in functions in C++. And this is it for today's video. I hope you understood the concept of pass by reference and pass by value. Make sure to subscribe to stay up to date with this C++ tutorial. Thank you for watching this video. Make sure to check out one of these end screens that will appear right now, and I hope to see you in the next video.